input validation, exception handling. Those are both very important security concepts. Most of our security problems come from the user, right? But the other part of it is the user is using code that is not safe. And so it's becoming a much bigger deal in software development, computer science, and all that to write secure code.
Especially nowadays.
Hmm?
Especially nowadays with AI writing half the code. That's why we got bad Windows update probably.
Oh, yeah, because the AI doesn't care if it's secure or not. I mean, it does help you build up things quickly, but then you have to futz around and fix it. And you have to know what you're doing. You know, if you're totally a vibe coder, good luck trying to find a job because anybody can vibe code. But you need a computer engineer who can actually look at AI and say, okay, that's stupid. Why are they doing that? One of the important concepts is something called input validation. And this is input validation. So if your program can only handle from numbers from 0 to 10, and somebody puts in an 11 that crashes the computer, you did not have proper input validation. You want to catch that ahead of time. So input validation means outside the range of what the program can handle. It's not something that will generate an exception necessarily. They do work hand in hand. So I'm validating, is the integer positive? If it's not positive, I want them to enter and keep going until they enter a positive number. And so the loop just keeps going and going and going. And here's a good example of the continue loop. I'm going to continue, which means I'm going to go back to the beginning, say input your age, and eventually you're going to get a positive number or you will not get any further in the program. So that's the input validation. Now we want to also handle, what if they put in the wrong type of input? You're asking for your age, but what if they type in ONE? That is not the type of input your program is designed to take care of. So if I do this, normally we'd have this big long line of exceptions, but we handled the exception. So we've done exception handling in Python. In Java, it's pretty much the same. C++, again, yes, that's a whole different kettle of fish. Is invalid literal for int with base 10.1 very helpful to your user? No, that's what comes out of the Java programming language to tell you what's going on. So what's a literal?
The type of variable it is.
A literal means that it's something that you typed in that's not stored as a variable. So if I literally type in O1E, that's a literal. So the ONE is literally what I typed in, and that's why it's called a literal for, and it shows you the function. This int is looking for a base 10. It's not looking for a string. That's kind of how you would interpret that, but you have to know what each of those things means. Is that helpful? Not to anybody other than a programmer. Now you know how to interpret it, right? More or less. We'll look at more of these later. Literal is I typed in something, it's invalid. I'm using the int method and I'm using it with base 10, which is our numbering system. And it says, this does not work. This is invalid. How did I get that? Well, when you handle exceptions, you can handle exception as E. E is the object that contains the error. So I printed out the error code, which is not useful to print out for the user, is it? It would be better to print out just your explanation. You could just say something went wrong, like some programs do. Uh-oh, please enter a whole number. And it keeps asking until you enter a whole number. Oh, that's not right. So the program doesn't explode. It just keeps waiting for you to type in the right thing. Now, if I type in a -1, what part of the code is handling that?
The comparison operation.
So if they type in the right type of number, we get past the exception handling, but the input validation says, yeah, you can't be -1 years old. You know, that's like 3 months prior to conception. So these are quite often can be used in together because they have different purposes. This is handling invalid input. This is making sure that your input is in the right range. So I probably should have something in here that says if your age is greater than 200, you know, you're probably Methuselah and he died some time ago. You just hope they don't type anything like that. So input validation is important. Exception handling is important to have secure code. Once we get to here, we know that it passed all of our tests. You know, and we're not running like programming tests. We're just doing input tests. Okay, that one worked. That's valid input. It is the right type of input. And now our program is fairly bulletproof. Somebody runs that, it's not going to explode. If the computer explodes, which just means you generate an exception, if you generate an exception with input and you allow somebody to do that, they can figure out, I mean, you have to be a really good programmer, hacker, whatever to do this, but you can put in the type of input that will overwrite other memory, adjacent memory, and then you can get the computer to do other things. Or it corrupts the memory and the program stops running properly. Java and Python are very safe. They don't allow that to happen hardly at all. I don't know if you remember a year or so ago, it was prior to President Trump. They were like saying, okay, anything programmed for the White House or the government has to be in these type safe languages. C++ is not one of them. You have to do it all yourself. With Java and Python, for example, they're managed, which means they take care of a lot of things for you. Where C++, you have to do everything yourself. So if you do everything yourself and do it fine, it can be very secure, but that's built into Java and Python. C#, for example, also has that. It's a managed language. C++ is the Wild West. And what does type safe mean? I thought somebody was going to ask that. What was? You just couldn't figure out the hand signals, right? Is a type safe programming language. Let's see what that means. See if it actually is what it means. So a type safe language enforces type. So they're talking about what does type mean? Because I think Owen said it. Didn't you say data type? For type safe? Well, anyway, type means data type.
Oh, yeah, for the
Yeah.
literal, that's what I'm talking about.
Yep. So variables have a data type. What's a data structure? We've been using them since like this 6th or 7th week in Python last year. A data structure is a variable that stores more than one piece of information, a list, an array. Those are all data structures. That's what it's called in computer science-y stuff. So they minimize things that can go wrong. So type is referring to the data type. All right, moving on from that. Now you can write code for the government, right? Maybe not.
Some very unsafe code.
You can do what?
Maybe some very unsafe.
Well, yeah, I don't know how, well, beginning code is never very safe. But this one is pretty safe. You know, I'm handling exceptions, I'm validating input. Those are two. Do you have to validate input, validate all input and try to catch all exceptions? No, it's impossible. You try to do it in the major pieces that might explode, which is always user input. Anytime you get user input, there's a problem. You can't control that. The user can type in whatever they want. That's usually where you're going to use input validation and exception handling. Usually. All right, moving on to, oh, here it is, squares and cubes. That's just like how to print squares and cubes. I don't know if we've done /t before as an escape character. Do you remember what an escape character is? That's why this is in here, it's to review escape characters.
Because we did slash n and postal time, right?
Yep. Yep, so slash n slash t are just quick ways to line up stuff. It's not the best. Because if you get something that's a little bit over, it pushes everything over and makes a mess. Because it's a set amount of distance. So this is like pressing tab on your keyboard. So if I'm typing something, I have a heading, right? I press tab, I can type another heading. The problem with using the default tab stops is I pressed one tab and that didn't work, did it? Because the length wasn't right. So there are limitations of slash T. There are other types of formatting that we can use to have everything line up nicely. We just haven't gotten there yet. But I mean, these are some of the things for quick stuff. You can use slash T for tab. And slash N, we've used slash N before. And in this case, this actually works because we print out dashes and nothing is, if the number got too long here, then it would push this over, wouldn't it? And we'd have a mess. But sometimes it's just a quick way to make things look nice in a tabular format. Do we have all the helpful libraries that Python had to do that for us? No, not in Java. All right, so we're gonna write a tic-tac-toe game. Actually, that'd be a good challenge. It's tougher than you think. So a tic-tac-toe board can be represented as a nested list, and this is the common representation. Commonly, when you're writing games, you have your background data structure and you have your front end display to show you what's going on. So you manipulate this, the result displays over here. It's a very common programming thing. So right now, we just have randomly putting X's and O's wherever we feel like it. So really, that's not a data structure for anything. But it's where you start with tic-tac-toe because you have an array of arrays. I'm sorry, a list of lists. If it was Java, it'd be an array of arrays or whatever. So how do you work with two-dimensional arrays? That's another term, or two-dimensional lists. You have to have two numbers. 0 represents what? 0 represents the row, so 0, 1, 2. The column is represented by 0, 1, 2. So if I wanted to choose this one, what would the numbers be? If I wanted to pick the one in the middle, what would my indexes be? First, you do the row, which is index
2.
Starts at 0.
Oh,
And then you do the column, which is, so it'd be 1, 1. Pretty much in any language I've worked with, when you do a two-dimensional array, it's something slash something comma this to indicate that particular thing. So if I wanted, oh, here's a loop that iterates through, but let's just do an example of printing it. So if I want to print the board, and I want to print a particular spot on the board, I have to say 0, 2. Whoa, 9 is not going to work, is it? There. Probably have to put quotes around it. There. No, that's not right. That other one should have worked. We'll do it with F-string formatting. Now, what did I do wrong here? Overload 2 is the closest match. Okay, that's great. When you're doing something and then your brain goes,
I don't think.
no, you don't need the comma. Owen fixed it. I had the wrong syntax for showing this. So you do board, list index for the outside list, right? 0, 1, 2. This one for the inside index, 0, because we know we're starting here, 0, 1, 2. So you start from the outside and work in, and no one fixed it, and it's recorded. And there it is. It's an X in that particular one. Most of the time, you're going to access it not individually like this. You're not just going to hard code it. You're going to use variables to say, oh, I placed it here, and then it's going to go through and print things. So when you're doing a tic-tac-toe board, you manipulate the data structure behind it, and then you print out the result. So how do you go through a list inside a list? You have two loops. You go through the outside first. So we go to row 0, right? Then inside of row 0, we go through each column. And if I'd looked down here, I would have found the right syntax, wouldn't I? So this is a variable rather than being hard-coded. And what that's going to do is go through each, the first time around, it's row 0. We go 0, 1, 2. Second time around, this is row 1, 0, 1, 2. This is row 2, 0, 1, 2. And the reason I put a tab is just to separate it out so it looks nicer. There. So this is not printing out the entire thing in a lovely looking format. What this is doing is demonstrating that we're doing the exterior loop, row 1, and we're going through that, the interior loop goes through the columns. Then we do row 2, the columns of that row, row 1, row 2, and the columns of that row. So that is a nested loop, and tic-tac-toe is just what I thought of when I was going through this. Because everybody knows tic-tac-toe. Do you know how to do tic-tac-toe, Eliza? Okay, so not everybody knows how to do tic-tac-toe. I do have a tutor who can help you though.